Here we want to take a look at compound inequalities. Now these are inequalities, but they have the word and or in them. The word and might be actually implied as it is in our examples here. What we're going to do is we're going to solve and write the solution in interval notation and graph the solution sets. Okay, so this first one, there is no words in it, but really if I read it correctly, it's saying -3 is less than 2x plus 5 and the 2x plus 5 is less than or equal to 7. So the word and is there, it's just implied. Over here, we can't make any kind of single statement when the word or is involved. It's either this is true or this is true. We can't join them in any fashion. All right, so let's take a look at how we would solve this first one. Basically, we're going to do it the same way we would with a single inequality. We're just doing it in 3 parts instead of just 2 sides. So if I'm solving for x, I would want to subtract the 5 so that I get just the 2x. I'm going to subtract that from both ends as well as in the middle. That leaves me with -8 is less than 2x is less than or equal to 2. Again, I want just the x, so I'm going to divide by 2. If I do that in the middle, I must be consistent and do that to both ends. So we get the final inequality, -4 is less than x is less than or equal to 1. As an interval, that would be with an open parenthesis, because we don't want to include the endpoint, -4, comma 1, close bracket to show that the endpoint is included. Now, if you have trouble getting that interval notation, sometimes it's helpful to go ahead and do the graph first. So we would do our number line, we put our numbers that are our boundaries, the -4 and the 1, and where is x? It's in the middle of those two numbers. So the included solution is in between the -4 and 1, so we'd shade that, and again, parenthesis because not included at -4, bracket because it's included at 1. And then I drop the number line, and that's basically what my interval is going to look like. All right, let's take a look at this one over here. In this one, I'm actually solving 2 separate inequalities. Okay, we're going to, again, add 5 to, in this case, actually add 5 instead of subtract 5, sorry. We're going to add 5 to both sides here, we're going to add 5 to both sides here, and we come up with 2 new inequalities. First one's 2x is less than or equal to -2, or 2x is going to be greater than 6. We want to get x, so we're going to have to divide everything through by 2, and we get 2 new inequalities. X is less than or equal to -1, or x is greater than 3. Now both of those things can't be true at the same time, right? So we actually have to come up with 2 separate inequalities, excuse me, 2 separate intervals. If it's easier, again, draw the number line first. Do the x is less than or equal to -1 by putting -1, and it's less, so we're shade to the left. We put a bracket because we include the endpoint. For x greater than 3, we start at 3 and go to the right, and we use a parenthesis because we don't want to include the 3. And then we're going to drop those number lines and really recognize that this is -infinity down here up to -1. That's my first interval. Union, and then my second interval here is going to be 3 up to positive infinity on this side. Let's take a look at a couple more examples real quickly. This one's an or, and then this one's again the applied and. So in this first one over here, letter C, we're going to divide both sides by 2, get x is less than 4. This one we're going to subtract 3, and we're going to get x is greater than or equal to 7. Draw my number line first, get 2 separate sections. Every time you have 2 separate inequalities, you're going to get 2 separate sections on your graph. You're going to get 2 separate intervals. Okay, so if you got 2 here, you're going to have 2 everywhere else. Over here, we're going to, this one's a little different, we're going to have to subtract the 6 because that's a positive 6 there, and that'll get me this new inequality, -10 is less than or equal to -2x is less than or equal to 8. Careful here, because if you divide by a negative, remember that means you flip your inequality symbols, so we end up with 5 is greater than or equal to x is greater than -4. We want to put it in number line order before we graph it or come up with any kind of intervals. So let's start with the -4. That's going to have to be less than the x. See, it's still got the little point towards the -4, and that's going to be less than or equal to the 5. Okay, now I can get my interval -4 to 5 with a parenthesis on the -4, not included, bracket on the 5, included.